Hello and welcome to IMS Fundamentals Part 3, where we're going to talk about the IMS Dependent Regions. And I'm Deepak Kohli. I'm with the IMS Product Management Team in the Silicon Valley labs of IBM. Here's my email ID, deepak@us.ibm.com. Feel free to email me if you have any questions. So let's go ahead and get started with IMS Dependent Regions. So this is our agenda. In our Part 2 video, no, there's a typo. It says Part 2. It should say Part 3. In our Part 2, we talked about the IMS control region. We talked about DBRC and DLIBATCH region. So here in Part 3, we're going to talk about the IMS dependent regions, the MPRs, the IFP, BMP, JMP, JBP regions. And we'll also talk about something a little separate from the online environment called the DLIBATCH region and the IRLM address space. So let's do that. Again, here is our IMS online architecture overview. We talked about the three system address spaces in the previous video, which is the control region, DBRC, and DLIBATCH. And today now we're going to focus on the dependent regions. So let's do that. The dependent regions, this is where application programs execute. The reason they're called dependent regions is because these regions are dependent for services on the IMS control region and DBRC and DLIBATCH. There are different types of dependent regions. There's MPR, which is message processing regions. There's BMP regions. There's IFP regions. There's JMP regions. There's JBP regions. So we're now going to spend some time and talk about what the differences are between these different types of regions. Also, the maximum number of dependent regions that you can have, including threads coming in from CICS or ODBA, in versions of IMS prior to version 13 was 999, and with IMS 13 and onwards is 4,095. So you can have up to 4,095 dependent regions starting with IMS version 13. And any combination of these, by the way, any combinations of MPRs, BMPs, IFPs, JMPs, or JBPs. So let's talk about MPRs. MPR stands for Message Processing Regions. And these are regions where you have application programs, and they have a certain characteristic. These application programs typically process transactions. And the nature of transactions is such that typically there is some human being sitting at a device entering these transactions, and they're waiting for a response. So these transactions don't typically do a whole lot of work. And response time is very, very important. And IMS typically promises what's known as sub-second response time, less than a second. So, you know, when you go to an ATM machine and you dip your card and you say, give me $100 for my checking account, that's a transaction, right? And that has to be processed in what's known as sub-second response time, less than a second. And so the programs that run in MPRs are not designed to do a whole lot of work. They shouldn't be. They should simply be processing transactions one after another, and they should be doing it really, really fast. MPRs themselves are started and stopped by operations. So typically when you start up IMS, operations will fire up some number of MPRs, and then programs will get scheduled in these MPRs. The programs that run in these MPRs are called MPPs, Message Processing Programs. And these MPP programs will then say, okay, I'm going to start processing transactions, and it'll tell the scheduler, go get me a transaction. And the scheduler will pick a transaction based on some priority scheme, and then the program will process the transaction. It'll be done with it. It'll be finished, and then it'll ask the scheduler for the next transaction, and so on. So that's what these MPPs do, is they sit there and they process one transaction after another. Different programs run in these regions through the course of the day. What that means is, you know, you may have a program that comes into an MPR, and it processes only deposit transactions. And then when there are no more deposit transactions, or we've processed more than enough, then that program will be kicked out, and another program will be brought in, and it may process a different type of transaction. For example, it may process withdrawal transactions. So you can have different programs that come in to these MPRs, they do their work, and then they leave. Then another program comes in, it does its work, and then it leaves. You can, if you want to, for performance reasons, designate some of these programs as WIFI, or you can designate transactions as WIFI. WIFI stands for wait for input. So you can actually have a dedicated program in an NPR sitting there all day long waiting for input. And you might want to do that, for certain transactions that are high priority. They need to be processed really fast, and you can't wait for a program to be loaded into the NPR and then process those transactions. You want to have a program waiting there for you as soon as the transaction comes in. As I mentioned, the scheduler decides which transactions will be processed in an available NPR, and then the appropriate program is either loaded from the program library, or the program might be preloaded into an NPR. That's another thing that performance tuning professionals will do in IMS, is they'll say, look, I know these 5 programs are very, very important because they process important transactions, so let's just preload them into the NPR. So these programs are simply sitting there, and they can be invoked, and so we don't have to go load them in from the program library, right? Programs in NPRs can also call Java programs, right? And programs in NPRs can access, of course, IMS databases, but in addition to that, they can also access DB2 tables using what's called ESAF, External Subsystem Attached Facility, which is basically a facility that allows programs in IMS to go access or go talk to DB2 and access DB2 tables or DB2 databases, if you will. A little bit more about NPRs. Let me give you some more information on MPPs running in NPRs. So here in my example, I've got a control region that's up, and of course I've got DLIBATCH and DBRC and all those other address spaces. I've left them out of the picture for simplicity's sake. And then I've fired up 2 NPRs. I've got NPR1, Message Processing Region 1, and I've got NPR2, Message Processing Region 2. And in the JCL of the NPR, you can specify what classes of transactions it processes. And you can specify up to 4 classes of transactions. So in this case, NPR1, for example, processes Class 2, Class 3, Class 4, and Class 1 transactions. Whereas NPR2 processes Class 4, Class 5, Class 6, and Class 7 transactions. And so when an NPR comes up, it talks to the scheduler sitting in the control region and says, hey, scheduler, I'm an NPR and I process transactions and I've just come up. Tell me which transaction you want me to process. And the scheduler then looks at the classes of transactions that the NPR can process. And then it says, okay, I'm going to start with the first class that's listed in your JCL. So in this example, NPR1 it can process Class 2, 3, 4, and 1 transactions. So the scheduler is going to start with Class 2 and it's going to find the highest priority Class 2 transaction. Every transaction can be assigned to a class as well as it can be assigned a priority. And so it goes into the message queue pool and looks at all its Class 2 transaction, finds the highest priority transaction, and then tells the NPR, listen, here's a transaction I want you to process. And then the appropriate program for that transaction is then either loaded into the NPR, if it doesn't already exist in the NPR, or it might already be preloaded. Somehow we get that program into the NPR, either preloading it or actually loading it from the program library. Then the program is kicked off and it'll process those transactions. It may process more than one. You can specify how many transactions it is limited to process. And once that program is finished, it then terminates. And then the NPR becomes available again. And then the NPR can turn to the control region and can say, hey, I'm available now. That program is finished. Now tell me which transaction you want me to process. And the scheduler goes through the same process, finds another transaction, and then tells the NPR, go ahead, load that program in, and let's process these transactions. So this is what goes on all day long. Now, by the way, it's quite possible that you can have an NPR that talks to the control region and says, I'm available, tell me which transaction to process, and there are no transactions that can be scheduled into that region at that particular time. And so then the dependent region simply, or the NPR simply sits there and waits for work, right? It's simply sitting there and waiting. So this is basically how NPRs work and how programs in NPRs work. Now, when a program is scheduled in an NPR, the first thing it will do is it'll say, get me my transaction, get me my message from the message queue pool. And the IMS control region will give that program the transaction. The program will then examine that transaction, and it will then do some number of database calls, maybe do some database updates, and then it'll generate a reply message to be sent back to the end user, and that reply message is also placed in the message queue pool. And finally, when the program either terminates or reaches a commit point, then we take those outbound messages and then send them back out to the end user, right? So this is basically how NPRs and MPPs work. Some final thoughts on NPRs. It's not uncommon for an IMS shop to start up some number of NPRs in the morning when IMS starts up. And then, if the queue of IMS transactions is growing and the queue is getting longer and longer, operations may start up some more NPRs. It's kind of like when you go into a bank, right? When you go into a bank, if the line is getting longer and longer, what does the bank management do? They'll open up another teller window, right? And it's the same thing here. You can think of NPRs as these teller windows that process transactions. And then, of course, when the queue is dropped down and there isn't that much processing to be done, you can shut down some NPRs. So it's not uncommon for IMS shops to do that. And of course, I think I mentioned this, programs running in NPRs can call Java subroutines, but the first application program scheduled in NPRs cannot be a Java program, right? So that's what NPRs do. They process transactions. They don't do a whole lot of work. They look at a transaction, they do whatever the transaction wants done, and the transaction usually completes within sub-second response time. Now, there's something called IFP regions, but before we talk about IFP regions, I need to mention what is the FastPath feature of IMS. The FastPath feature of IMS was requested by, I believe it was the Japanese customers. They said, listen, IBM, this is really great that IMS can process transactions in sub-second response time. This is good, but we want something faster. And so this FastPath feature was designed to provide faster processing. And the FastPath feature involves two things. It involves a set of databases. There's what's known as data entry databases, which are designed to get the data into the database very, very fast and then process it later in batch mode. And then there's main storage databases. These are databases that reside in virtual storage, so you don't have to go out to the DASD device and get them. And any program, by the way, it doesn't matter whether you are running a FastPath region or not, any program can access these FastPath databases, these DEDBs or MSDBs. In addition to having these fast databases, we also have transactions which are termed as FastPath exclusive transactions. And these are transactions that run in another type of dependent region called IFP, IMS FastPath regions. And these transactions run faster than non-FastPath transactions. And why do they do that? Well, what makes them run so fast? So let's talk about that. So the IFP regions are used to process FastPath exclusive transactions. And these FastPath exclusive transactions, they do not go into the message queue pool, right? They don't get queued in the message queue pool and then wait to be processed, right? That's the rat race, if you will, where transactions come in, they get queued, and they're processed in a priority manner. No, FastPath transactions don't go into the message queue pool. They go into a dedicated buffer known as the EMH, the Expedited Message Handling Buffer. So we actually have a place. Remember, non-FastPath transactions, when they come in, they go into the message queue pool. And if there's no room in the message queue pool, then what do? We move them out to the message queue datasets, right? And that can all impact performance. But not so with FastPath. Every FastPath transaction that comes in goes into a dedicated buffer called the EMH buffer. FastPath transactions are processed first in, first out, FIFO. You don't have priorities and people competing, none of that stuff. You come in first, you get processed first. FastPath transactions are smaller in size. They're single segment transactions. They are also what's known as response mode transactions, which means that when you enter the transaction, your keyboard is locked. You can't enter another transaction until we finish that transaction. FastPath transactions are non-conversational, meaning they're stateless. We don't keep state from one iteration to the next. And you would define these transactions in the IMS sysgen as what's known as FastPath transactions. And also, FastPath transactions are processed in IFP regions, and they're processed in what's known as WIFI mode, wait for input mode. So when these transactions come in, there's already a program sitting in an IFP region waiting to process them, right? So that's the nature of IFP regions. And this is, on this next page here, the heading says Expedited Message Handler. Basically what we're saying is that when fast batch transactions come in, they don't get handled by the IMS queue manager. They don't go to the message queue pool. They go to a buffer called the Expedited Message Handler Buffer, the EMH buffer. So you have a dedicated buffer, so you don't have to worry about transactions being thrown out onto the message queue datasets. Okay? So we talked about MPRs, we talked about IFPs. Now let's talk about BMPs. BMP stands for Batch Message Processing Programs. The prior two regions that we talked about, MPRs and IFPs, they process transactions. Transactions usually are required to be done within sub-second response time. What if you wanted to do batch work? You know, go through your entire database and figure out all the stock trades that were done for the day and then generate a report. You know, these long, elaborate type of processing. That's done by these regions known as BMPs, right? So they do long batch type processing. BMPs are submitted by operations, and as soon as the BMP region is submitted, the program starts up in the JCL. We know what program is going to be executing. The program goes off and runs for several minutes, does all it needs to do, does its elaborate processing and report generation and whatever it does, and then when the program terminates, the entire BMP region is gone. This is not what happened with MPRs. If you recall, with MPRs, when a program terminates, the MPR turns around to the control region and says, hey, control region, that program finished. I'm available to process another transaction. Tell me what other program to bring in to process another transaction. With BMPs, it's different. You submit the JCL, you specify the name of the program, that program executes, it does its work, and then that program goes away and the region goes away too, right? BMPs may or may not access the message queue. In other words, they may or may not process transactions. There are two types of BMPs. There's what's known as a message-driven BMP, where they'll process input messages or transactions and insert outbound replies to the message queue pool, and you would specify in the JCL via the in equals parameter, you know, which types of transactions it's going to process. And then the other type of BMP is what's known as a non-message-driven BMPs. They don't process transactions. They simply do long, elaborate processing by going through the databases or data sets. GSAM files is another form of data set. And they can insert outbound messages, but they can't take input IMS transactions. So two types of BMPs, message-driven and then non-message-driven BMPs. But again, they're designed to do long, elaborate batch-type processing that may run into the minutes. Where do you specify that a BMP is message-driven or non-message-driven? That's done in something called the IMS sysgen. I don't think we've mentioned this word sysgen, so let me say a few words about that. If you recall from our first video, IMS was designed or developed initially in 1968 to support the Apollo spacecraft. And so speed, recoverability, data integrity were very, very important for IMS. That's the DNA of IMS, if you will. And so one of the things that you have to do with IMS, and over the years we've been sort of chipping away at this and trying to remove this, but still today, you have to do what's called the IMS sysgen. The sysgen is a way of predefining resources that IMS needs to manage. What are all the transactions that IMS is going to process? Well, what are the programs that are going to process each one of those transactions? What BMP programs are going to run? Are they message-driven BMPs or non-message-driven BMPs? All this stuff has to be predefined. It's typically done by the IMS system programmer, usually a guy called Bob with a very fuzzy beard. But anyway, but that's sysgen, and we do this because so that we have all these resources predefined, and so IMS will run faster, and that's the whole point of doing this. And here we're simply showing you how you would define a message-driven BMP and how you define a non-message-driven BMP. And again, it's the IMS system programmer that would go through this process. So here where it says application PSP equals HQ PGM program type equals batch. What that says is I'm defining a BMP called HQPGM, and program type equals batch says it's a BMP. And following that, we've got a transact macro, code equals HQ update, that says this program, HQPGM, even though it's a BMP, it's going to process transactions, and the transactions it's going to process is called HQ update. Right? So this is a message-driven BMP. A non-message-driven BMP only has the application macro and no transactions defined after it. All right? Just a little bit of information about how you define message-driven BMPs and non-message-driven BMPs in IMS SysGen. And this is typically, again, done by the IMS system programmer. Here's an example of a non-message-driven BMP being submitted for execution. In the JCL, there's an exec card, and then on the PARM statement, the first parameter says BMP, and then the second parameter is the name of the program, and the third parameter is something called PSB, which we will talk about in other videos of IMS. And then again, this is a non-message-driven BMP, and so all it's going to do is access databases and ZRS data sets, and then do whatever it needs to do. It's not going to process any transactions. Okay. So now let's talk about JMP's region. This is another type of region. JMP stands for Java Message Processing Region. These are like MPRs. Remember MPRs, message processing regions, they process transactions. Well, JMPs are also regions that process transactions. The only difference is the programs in JMP regions are written in Java, right? Now, if you're running IMS, if you're running any IMS system before IMS 13, there are some restrictions. JMPs only allow scheduling of Java applications. You cannot preload applications, and you cannot use ESAF to talk to DB2. This restriction of not using ESAF to talk to DB2, this was removed in IMS version 13. So basically, that's all JMPs are. These are environments. What IMS developed and noticed is that there's more and more Java programmers out there than there are, say, COBOL or PL1 or mainframe assembler programmers. And so to support that pool of talent out there, we provided this JMP region where you can now write Java programs, and they can now access IMS databases and process transactions and so on. Another type of region is called JBP, Java Batch Processing Region, and again, these are like BMP regions, right? They're like the BMP regions. The only difference is JBP regions, the programs are written in Java, but otherwise they're like BMP regions. And again, if you're running prior to IMS version 13, you have a restriction. You cannot use ESAF to talk to DB2. You can talk to DB2, but you just can't use ESAF to talk to DB2 from your Java program. This restriction was removed in IMS version 13. So there you have it. That's the online architecture of IMS. In video 2 or part 2, we talked about the control region, talked about DBRC, we talked about DLIBATCH, and in this video, we talked about the MPRs, the BMPs, the IFPs, the JMPs, and JBP regions. These are the different types of dependent regions that you can have. And you can have up to, starting with version 13 of IMS, you can have up to 4095 dependent regions. So you can go to town with that if you like. A couple of words about DLIBATCH regions and IRLM, and then I think we'll close up this video. Let's talk about DLIBATCH regions. The architecture that we went through and talked about those address spaces, that was the IMS Online environment. Sometimes IMS is shut down, and all you want to do is now do batch, long, extensive processing at the end of the day. So then you would submit these batch jobs, and these batch jobs are called DLIBATCH jobs. And they may read input, output files, and then they will access databases. The databases are allocated to these programs, and each DLIBATCH program will have its own log. It's not like the online environment where you've got one set of common logging facility, So that's what DLIBATCH jobs are. These are, they do long batch processing. They're started by operations by submitting JCL. Each batch region is a single address space, has its own log. The databases are allocated to that particular batch job, And historically, batch processing, or the batch window as they call it, is typically run at the end of the day after online is brought down. Although that's changing now. Now more and more people are doing concurrent batch processing as well as online processing, and we'll talk about that later on. IRLM, let's talk about IRLM. IRLM stands for Internal Resource Lock Manager, and it's an alternative to the PI. If you remember from video 2, we talked about that the locking modules in IMS are in the control region, and they're called PI. PI stands for Program Isolation. Well, an alternative to PI is you can use something called IRLM. And IRLM is an external lock manager. It runs in its own address space. It doesn't run within the control region. And you need this external lock manager. You actually must have it. You must use IRLM if you're doing what's called data sharing, and specifically if you're doing block level or sysplex data sharing. Because if you've got multiple IMSs, IMS 1 and IMS 2 and IMS 3, and they're all accessing the same database at the same time, then you need an external traffic cop, if you will. You need a lock manager that's going to tell the other IMSs, hold on a second, IMS 1 is updating this little piece of information that you need. Let it finish its updating, and when it's done, then you can access that data. And that's the whole function of a lock manager, is to maintain integrity of the data, right? So IRLM runs in its own address space. If you use IRLM, it must be started before the IMS control region is started. And by the way, DB2 also uses IRLM as lock manager. And if you're a shop that has DB2 and IMS, most shops do, the same IRLM address space cannot be used or cannot be shared between IMS and DB2. So DB2 has got to have its own IRLM, and IMS has to have its own IRLM, if you will. And here is a picture of data sharing, right? So I've got a KICS address space that's issuing DLI calls to access IMS databases. I've got an IMS batch program that might be accessing IMS databases. And I've got an online IMS environment. This is my control region, my DBRC, my DI SAS, and my MPRs, and they're all accessing the IMS databases at the same time. This is called data sharing. And when you do block level data sharing, which means that everybody can update at the same time, you need to have IRLM. You must have IRLM running in a separate address space. Okay? So there you have it. Now, I mentioned this, I think, in maybe video 2, but I'll say it again. There are other address spaces in IMS that perform other functions. They're optional. You don't have to use them if you don't want to. And here's a list of some of them. There's the IMS Connect address space. And the IMS Connect address space was introduced later in IMS's life because of TCP/IP. It's our TCP/IP gateway. Everybody nowadays wants to talk TCP/IP. Everybody wants to communicate via TCP/IP. And so we introduced this address space, which is our TCP/IP gateway. We also have something called the Common Queue Server for managing objects on what's known as a coupling facility. We have what's called CSL address spaces, and there are various CSL address spaces. There's OM, RM, SCI, ODBM, and there's also something called IMS Repository Service address space, server address spaces. So we'll cover all these other optional address spaces in later videos of IMS. So again, my name is Deepak Kohli, and I'm with the IMS Product Management Team. If you have questions, please reach out to us. Post your questions on the IBM IMS forum on LinkedIn, or send me an email, and see you in part 4. Thank you.